Okay, this is number 2 from section 4.2. Let's read the instructions. It says, find an explicit description of the null space of A by listing vectors that span the null space. Okay, so it sounds like they want a basis for this null space. That would certainly do it. But let me write down the matrix A. All right, so remember, by definition, it's in the null space X is if it satisfies this equation. So essentially, we just want to multiply this by vector X, set it equal to 0, and solve the system. And it looks like it's almost already in the right form, but this is the augmented matrix of the system. Really just have to add a last column of zeros. Okay. Well, it looks like the only thing I really need to do is work on this particular column. If I take the third row and divide by -3, that should put it in reduced echelon form. Okay. Because notice every non-zero entry in every row is to the right of the first non-zero entry of the row above it. And also, all of the other entries in those columns are zeros. Okay. So it looks like we will have some free variables and also some basic variables. So as usual, let's list them. And remember, the basic variables correspond to the pivot column. So it looks like x1, x3, and x5 are the basic variables. The free variables are the other ones. So that'd be x2, x4. And there are only 5 variables. Remember, that last column is never a pivot column. So let's characterize the solution set. So the first equation is really this when you solve for x1. So I'm really bringing 4x2 over to the right-hand side and making it negative, and I'm bringing -5x4 over to the right-hand side and making it positive. Okay. And that's consistent with the fact that x2 and x4 are both free. Now let's do the second equation. It looks like x3 is 3x4. And the very last equation just says x5 is equal to 0. Okay? So remember, the trick on these, if you're trying to characterize the solution set, is just to write everything as a single vector. But just put this thing only in terms of the free variables, which are x2 and x4. So x1, x2, x3, x4, and x5 is just 0. So that is our solution set. That's our null space, really. But let's put it in a nicer form. If I write down all the coefficients of x2, we've seen that trick before. Get that? Now write down all the coefficients of x4. We get that. So it looks like the null space is the span of these two vectors. That's the basis of the null space. And we're just supposed to come up with a spanning set for the null space of A. Well, this would certainly do it. A basis is always a spanning set, and we found the basis.